11.2, graphing square root functions. If you'll turn to page 590, we're going to go through the parameters and how the transformations move. These are the same thing that we've been doing all year long, except this time it's square root functions instead of either quadratics or cubics. They are square roots. The information is the same. So let's look at A. A, predict the effect of the parameter H. So on A, it has x minus 2 underneath the radical. The graph is a translation of the graph, and it moves which way? Remember, everything under the radical is the same thing as if it was in parentheses. If it says minus 2, it's going to go which way?
Right.
Right. It's always opposite, and it translates right 2 units. Okay, what about plus 2? It's a translation.
Right.
And it moves left 2 units. Questions on that? Okay, part B, predict the effect of the parameter K, square root of x plus 2. It is a translation of the graph, and it moves it which way? Up. Minus 2. Now we're talking about the K. It is a translation.
Down.
And it moves it down 2 units. Any questions? Page 591 at the top. Predict the effect of the parameter A. Now we're talking about the A, which is out in front. So we know out in front is a what? Vertical stretch. It doesn't change. It is what it is. Vertical stretch by a factor of 2. One half out front of the graph is a vertical compression. It doesn't change. It is by a factor of 1/2. Negative 1/2 out front is a vertical compression. Everything out in front of the square root is vertical. Vertical compression by a factor of 1/2. It is also a reflection across the x-axis. Negative 2 out front is a vertical stretch by a factor of 2. As well as a reflection across the x-axis. Any questions on that? Same old thing we've been doing all year long. Okay, let's go inside the radical now. Inside the square root. We're looking at the B. So remember the B, everything inside the square root is opposite of what you think. Square root of 1/2 x. The graph is a horizontal stretch. By a factor of 2. You got to flip the 1/2 over. Square root of 2x. The graph is a horizontal compression. by a factor of 1/2. Square root of negative 1/2 is a horizontal stretch by a factor of 2, as well as a reflection across the
Y-axis.
y-axis. The next one, square root of negative 2x, is a horizontal. Anything underneath the radical is horizontal. Horizontal compression by a factor of 1/2, as well as a reflection across the
Y-axis.
y-axis. Any questions? Okay, turn to page 593. Your turn. Okay, what we're going to do now is we're going to take our graph. On our graph is the parent function. This right here is the parent function. It has 2 reference points, which are 0, 0 and 1, 1. They are on the parent function, so we're going to use those reference points. It tells us to graph it, the transform function, on the graph with the parent function, and then describe the domain and the range in set notation. So we're going to make a T-chart, just like we did before. Remember, everything here to the x is everything under the radical, and it's opposite of what you think. So what would be happening to the x?
X plus 2.
X plus 2. Everything else out in front of the radical or after the radical happens to the y. So this would be negative 3y plus 3. If I put 0 in for the x, I get 2. 0 in for the y, I get 3. Positive 3. If I put 1 in for the x, I get 3. And if I put 1 in for the y, I get 0. I'm going to plot those 2 points. 2, 3 would be right there. That's going to be my starting point. And then 3, 0 is right there. So my graph would curve just like that. I kind of missed the point there.
It just starts from that.
It starts from the point. When you put in 0, 0, that point will be your end point.
Okay.
Okay? Now I'm going to do the domain in set notation, x such that. Here is where it starts on the x-axis and it's going all to the right side of that point, and that point right there is 2. It starts at 2. So x is greater than or equal to 2. My range in set notation, y such that it goes all the way up to positive 3, and everything below that, y is less than or equal to 3. Questions? That's it.
So it would be y is less than because
Because it's
it
going
goes
down.
Okay.
Any other questions on that one? All right. Number 5. Okay, remember our reference points are 0, 0, and 1, 1. We're making a T-chart. What are we doing to the x? 3x minus 2. And what are we doing to the y? Plus 1. Don't forget, everything under the radical is opposite. That's why we went with 3x minus 2. Put a 0 in here. 0 will give us what?
Negative 2.
Negative 2. 0 in for y.
1.
1. 1 in for x. Substitute 1 in for x.
1.
1. And 1 in for y.
2.
2. We're now going to plot those points. The very first point is going to be our end point. So negative 2, 1. And then 1, 2. So our graph would go just like that. Our domain. We want to know from here, where does the graph go from here? It goes to the right. So our domain would be x is greater than or equal to
Negative 2.
negative 2. X such that x is greater than or equal to negative 2. In our range, y such that, here's the y value here. Does our graph go up or down from there? Up. And that value on y is 1. So y is greater than or equal to 1. Any questions on domain range or how you graph? Okay, turn to 595. Now we're going to write a square root function. We're going to take the graph and we're going to write the function. The book is going to tell you what form you want it in. It'll either have a B in it or it'll have an A in it, and the book will tell you. The end point, this point right here, is your HK. Okay, so that point is 1, negative 1. That is my H and my K. So really, I know everything in my formula except what letter? B. Okay, here's what you need to remember when you're looking for the B. H plus B and K plus 1. That's a formula that you need to remember. This is equal to the x value of our second point here. So what's our second point? 1.5, 0?
Yes.
Okay. So 1.5, 0. So this right here has to equal 1.5. So H plus B equals 1.5. And we know H is what? 1 plus B equals 1.5.